Now let us talk about installing the strain gauge by using the CNE adhesive. The strain gauge to be installed will be PF or P series. We mentioned about this in our previous videos. This kind of testings are normally the immediate testing, which is conducted under indoor conditions. And this is most commonly applied by the researcher who produce the test specimen in the laboratory. Once the concrete or mortar reach its matured age, the specimens are put into testing. The relevant strain gauge used will be the PF or P series, and the adhesive used can be CNE adhesive. Taking this as an example, this is about a laboratory load test on a mortar test specimen. The age of mortar is about 2 months. The specimen is cylindrical shape with the diameter of 100 mm and a height of 200 mm. The strain gauge used is this PFL 3011 3LT. By looking at the coding here, we know that this is the PF series, single element, 30 mm gauge length. It comes with the lead wire of 3 meters. The adhesive used is CNE. Let us look into the process. We want to bond the strain gauge. Use CNE adhesive to attach the strain gauge on the pre-coated surface of the test specimen. By the stage you would like to install the strain gauge, a pre-coating surface should have already been applied. This has been discussed in our previous videos. Assuming now the pre-coating surface has already been successfully provided, now when we want to install the strain gauge, it shall be installed onto this pre-coating surface instead of directly onto the test specimen. Now the process of installing the strain gauge onto the test specimen is almost exactly the same as installing the strain gauge on an ordinary steel. We have also discussed about the installations of the strain gauges in our previous video. After that, it will be securing the lead wire. You may use tape to secure the lead wire onto the surface of the test specimen. Handle the lead wire with care as it is very fragile, especially to the connections with the strain gauge. Make sure there is no undesired force exerted into the lead wire that may ultimately damage or disconnect the strain gauge. Once everything is completed, you may conduct a final check. Perform checks such as the gauge resistance and insulations resistance check. We also discussed about this kind of checking in our previous videos. This is referring to the gauge resistance checking by connecting both terminals of the strain gauge. With the tester here, you should be able to acquire the resistance as per the specifications of the strain gauge, which based on the coding here, the resistance of the strain gauge is silent in terms of the coding. When the relevant information is silent from the coding of the strain gauge, you know that the strain gauge has a standard 120 ohm. So when you test the resistance of the strain gauge, it should give you 120 ohm. And then you may try to test the insulation's resistance. Since concrete itself is not an electric conductor, I believe this shouldn't be an issue. With that, the installations of the strain gauge should have already been completed. Simply said, for you to install a strain gauge onto concrete, you will need to first prepare the surface, make the surface smooth, and clean from impurities, and then lay a layer of pre-coating before you can install the strain gauge. Now you may want to ask, is it a must to have a pre-coating onto the concrete surface before installations of the strain gauge? As if you could recall, you see some researcher apply the strain gauge directly onto the surface of the concrete without the pre-coating. Theoretically, this is applicable. However, this is conditional to several criteria. First, the testing should have been conducted under indoor conditions. Second, the test specimen shall be quickly tested after the installations of the strain gauge. You cannot install the strain gauge and leave it there for a long period of time before the testing starts. You might not be able to guarantee a good bond between the surface of the concrete and the strain gauge. Third, the surface of the concrete must be in good conditions and suitable for direct installations of the strain gauge. What does it mean by good conditions? The surface of the concrete should be smooth, properly abraded, clear from impurities, and after you have installed the strain gauge, you will need to do some visual inspections if the strain gauge is properly bonded onto the surface of the concrete. Now going back to the question just now, can you install the strain gauge directly onto the test specimen, which is the concrete and mortar, without the pre-coating? The answer is yes, you can, but under the three conditions that we mentioned just now. But if you really want a good result, and if you are not that urgent in terms of rushing your testing works, probably you can consider to lay a layer of pre-coating by using the PS adhesive before you install the strain gauge. If it is properly installed, by right you will have no doubt regarding whatever result that you have acquired from the testing. Next, let us talk about the effects of dampness of alkalinity on the CN adhesive. First, what is dampness? It is referring to the state of the surface where you install the strain gauge, which is slightly wet. How about the alkalinity? This one is due to the chemical compound for the reactions of the concrete or mortar during the hardening process. Now, in the existence of the dampness and alkalinity surrounding the pre-coated area, this may increases the hardening speed of CN or CNE adhesive. Now, if it hardens very fast, you might have difficulty to install the strain gauge in the precise locations, as you're going to work faster than usual before the adhesive hardens. Now, in this event, you may apply a generous amount. That means you apply more of CNE adhesive. When the amount of adhesive is more, this shall extend the hardening time of the adhesive so that you have more time to work with it.